All right, hi everybody. Hopefully you can hear this okay. I got asked to do this question here from chapter 23, number or problem 25. So it says here, find the current. So it says here, find the current through the through and potential difference across each resistor. So that's basically asking us to do a VIR chart, and here's our circuit right here. So, all right, I drew the circuit right here, and I also drew the currents going through the circuit. So I1 right here, that's the current going through what I called R1. So I'll call this R1, this one's R2, R3, and R4, like that. And then there's a 10-volt battery here. Every single one is a 5-ohm resistor, so I made my VIR chart, and that means all the resistors are going to be 5 ohms. And I think other than that, I'll pause there and go back to here. So again, current I1 is going through R1. That's also going to be the current, though, going through the battery, because we can see the battery is sharing the same wire with R1. Therefore, it's in series with that. And then we got basically I1 is going to split into current 2, and then that's going to split into current 3, and then that's going to split into current 4. So we got all those currents that are going to split, and then they're all going to come back together again here to become I1 again. So we could use the junction rule there, and I think I'm going to just use any rule I can in order to solve this, kind of whatever's easier on me. Okay, so this is a combo circuit. Not all of them are in parallel, not all of them are in series, but hopefully you can see that resistors 2, 3, and 4 are all sharing junctions with each other, and therefore they are all in parallel with each other. So I'm going to make these, so I'm going to collapse all these down into a new circuit. Let's see what that circuit looks like. I already drew them beforehand to make this video a little shorter. And so now I have a new circuit with I1, and then this resistor here, which I'll call RP. That's the parallel equivalent of that circuit. And I know that the sum of that 1 over RP is equal to the sum of each individual resistor. So that's basically 1 over R1 plus 1 over R2 plus 1 over R3, or their inverses, sorry. And so I could add all those up. 1 over RP is equal to 1 over 5 plus 1 over 5 plus 1 over 5. And this all adds up to 3 over 5. So that RP is going to be 5 over 3. And that ends up being something. I think it's 1.67 ohms. Let me just double check. Yep, 1.67. I should trust myself. So, all right, yeah, RP then is 1.67 ohms. So, and my method, by the way, of what I'm doing, I'm trying to collapse this all into the simplest circuit possible, finding out the current going through the battery, and then extrapolate back from there. So I'm going to make this the simplest circuit I can, use Ohm's law to find the current going through the battery, and then extrapolate back out to figure out what everything else is. So right now I know RP is 1.67 ohms, but then I still got 2 resistors here, and they seem to share the same wire. So I'm going to say that they're in series with each other, and so I'm going to collapse now this into the simplest circuit possible. I'll call this one RS because it's in series, and I'll get a new resistor here. So resistors in series, we've seen you just add up each individual resistor. So that's going to be RP plus R1. So that's going to give me RS is RP, which is 1.67, plus R1, which is a 5 ohm resistor, and I get that the series circuit is 6.67 ohms. So there we go. And now that I know that, I know the, so this is the voltage drop, or this is the voltage that the battery provides, and that's going to be all the, and so if this is the equivalent resistance, that all of that voltage is going to go to this particular resistor. So I can use then Ohm's law, our old friend, to figure out, so the Ohm's law is going to be the voltage drop across the battery divided by the equivalent resistance, which would be RS. So the current going through resistor 1 is the voltage drop across the battery 10 volts divided by 6.67, and I get a current of 10 divided by 6.67, about 1.5 amps. Nailed it. All right. And so that's the current that's going through the battery, which is also, as we said before here, if that's the current going through the battery, that's got to be the current going through R1. So I can plug that in for R1. The current going through there is 1.5 amps. And once again, once you have a row, then you could use Ohm's law to figure out what the voltage drop is across R1. So let's go ahead and do that. So using that, I'll find the voltage drop across R1. That's going to be the current going through resistor 1 multiplied by resistor 1 itself. So the voltage drop going across R1 is 1.5 times R1, which is 5 ohms. Let's see what that gives us. 5 times 1.5, 7.5. So that's a 7.5 volt drop. 7.5 volts. Yes, so there's that. Now I think I'm going to use the loop rule for everything else here. So let's go ahead and check out what that means. So first my loop will be this loop here. So I'll start here at the bottom of the battery, and I'll make a loop around like that. By the way, you don't have to use the loop rule for this, but I'm trying to show you as much as I can. So I'll make this loop. This is loop 1. So this is loop 1 right there. And basically, the voltage gained by the battery is 10 volts. And so this one we know takes, this is going to take 7.5 volts. Because we just found that out. Yep. And that means then this is the only other resistor this loop goes through, which is R2. That means R2 is going to take the remainder of those 10 volts. So it's going to take, this is 7.5 volts, right? So the voltage drop provided by the battery has to equal the voltage drop across R1 plus the voltage drop across R2. And so if the voltage drop provided by the battery is 10, I could subtract 7.5, because that's what that one is. And that's going to give me 2.5 volts. And that's going to be the voltage drop across R2. So this one's going to be 2.5 volts across R2. I can write that in there, 2.5 volts. And now we're going to see my life is going to get much, much easier. Because again, all of these are in parallel. So if the voltage drop across R2 is 2.5 volts, then that must also be the voltage drop across R3 and R4. And you could do other loop rules to find out exactly the same thing. So that means R3 and R4 are also going to be 2.5 volt drops. And again, I can use Ohm's law to find out all of these. I'll just do one. So I'll use Ohm's law for this one. So that means the current going through resistor 2 is going to be the voltage drop across resistor 2 divided by resistor 2 itself. So the current going through resistor 2 is the voltage drop, which is 2.5, divided by resistor 2, which is 5. I think that just ends up being 1/2. And so I can plug that in there. And you're going to see that all of these are going to be 0.5 amps. So there you go. There is the VIR chart for all those. So the voltage drops across each resistor, the current going through each resistor, and the resistance itself. Again, the big method you're often going to use is you're going to collapse it into the simplest circuit that you can, finding out which resistors are in parallel or series. And once you got that, you can then figure out whatever the unknown is. In this case, it was the current, and extrapolate that. And then you pull back out of there, and you get all this stuff. And then feel free to use the loop rule and the junction rule as necessary. Hope that helped. All right. See you guys. Bye.